Great pleasure to be here. Thank you to the organizers for inviting us, specifically because a big part of my presentation has nothing to do with body scanning. But before some of you get ready to leave, I promise you there will be some information on this topic later on in my presentation. As the title suggests, it's going to be mostly about photogrammetry, and thank you, Christian, for already giving a concise definition of what it is, so I don't have to spend time on that. But I assume that most of you here are quite familiar with this method. So yes, our company Rigsters started as a scanning studio based in Copenhagen. Initially, we aimed at purely providing services. We worked with fashion brands, cultural heritage institutions, film productions, and video game developments. So photogrammetry is a great match for these types of use cases, as we mainly focused on the visual fidelity of our scans, and to a lesser extent on geometrical precision. That is not to say that it cannot be achieved with photogrammetry, but it is of lesser importance in our particular workflows. Further along the way, we started developing tools for sort of making our lives easier, especially when the projects became larger, and slowly transitioned into being more of a hardware and software developer, while at the same time still doing service projects. And with a particular focus on automating the process and focusing on large-scale products that involve mass digitization. So yeah, as mentioned, photogrammetry pretty much involves taking a lot of photos that can be done in many different ways. And we started with the simplest one and accessible to everyone, which is handheld photogrammetry. So you take some cameras, invite your friends, go to a park, find a nice sculpture, and do this dance around it for, I don't know, 10, 15, 20 minutes, or until you feel that you have enough data. And then come to your office or home and start processing it and hope that everything works out. We got quite good at it. We scanned what we think are the coolest sculptures around Copenhagen, and slowly started expanding our use cases to other things that can be useful for companies to get scanned. As I mentioned, projects tend to grow if you're doing them well, and doing tens or hundreds of objects handheld quickly becomes a very tedious process and quite time-consuming. So some form of automation was necessary, and again, starting with the simplest and most accessible tools that we had, a tripod and a turntable, already speeds up the process quite a bit. Unfortunately, we don't always or almost never scan perfect cylinders or spheres, so turntable has its limitations. With that, we decided to get a bit more creative and started putting together like aluminum profiles and motors in an effort to automate some sort of capturing sequence. In this case, rotating the camera and the lighting system around the object, which was suspended in the center of this contraption, rather than using a turntable. So works relatively well. However, when it comes to scanning an object of a different size right after, let's say, this one, we would need to readjust the lights, readjust the camera, and pretty much all the time that we win on the scanning process, we lose on the setup. So that wasn't really working. I went back to the drawing board and came up with this design. So instead of rotating the camera around the object, we use a gantry principle and went back to the turntable in order to be able to achieve the same effect, essentially as with a tripod, but we didn't have to move the tripod, readjust the heights. The system was able to do it by itself. Problem with this particular prototype, that when we had to move offices, it didn't fit through the door. So that was clearly a miscalculation on our end. So went back to the drawing board and redesigned the system in a more sort of elegant and portable fashion. With such a system, we could already travel, so we were able to pack it and put it in the back of a van, go on location, and do a project on site if that was necessary. One such project, and one of the sort of first very challenging projects, but luckily the one that also served as a great proof of concept for the system, was digitization of an entire whale skeleton at a natural history museum in Copenhagen. The skeleton was disassembled and was sitting in a basement, like a parking lot of the museum, which luckily had enough space to fit our system, and we were able to automate the capture of all of the parts that would fit a turntable. And you can see the system operating in the video right here. The total project involved more than 100 bones that were each scanned individually, and I would say roughly half of them were scanned using the automated system. And here you can see the early version of the software and how we were able to position the camera angles towards the subject. And in the meantime, my colleagues are scanning the larger parts, handheld. Right. And here's the final result of a reassembled whale that we worked with a researcher that studies these mammals that helped us to correctly assemble the skeleton back together. Another interesting use case that came about from having this system is ability to explore photogrammetry not just in the visible spectrum. So working with researchers at Globetech, we were able to experiment with conducting photogrammetric capture using ultraviolet and infrared radiation in order to collect more data about the object, in this particular case, traces of pigments that were not visible to the naked eye, and as you can see on the neck, in one of the photos, traces of the repair that were conducted at some point in the past. Moving to a completely different topic, apart from cultural heritage, we also worked a lot with the fashion industry, and particularly shoes was a very popular item that people requested us to scan, which again, to our benefit, we already had a system that was able to handle it quite well. And moving forward, objects of various shapes and sizes, which are more tricky to accommodate, but nonetheless designing the system that would adapt to an object rather than trying to find a unique approach every time proved to be quite beneficial to a point that people actually started showing interest in the system itself and not just their services. With that, another couple of years of redesigning, polishing, and making it more user-friendly, our system that's called Arago became a commercial product which is currently being used by studios around the world, cultural institutions, museums, video game companies, and film studios. And to dive a bit deeper into how the system works and sort of what compiles the software of this device, it's essentially split into 3 steps. First is your camera configuration. We use regular DSLR cameras, and we can support pretty much any camera that can be triggered with a trigger cable. We then conduct something we call a pre-scan. We use a depth sensor to make a very rough shape of the object we intend to scan afterwards, in order to know its exact shape and its location in space, which is done by a simple turntable rotation. After this is done, the model can be slightly edited, and then it's essentially is being used as a targeting system for photogrammetric capture. So we take into account your camera settings, your field of view of the camera, your depth of field, and then apply basic sort of rules of thumb of photogrammetry of having sufficient overlap of in-focused areas on the mesh. And we have a color map that indicates if we're missing an area, we can always readjust the cameras or add more positions to account for that. After this is done, it's just about clicking a button, and the system will go through all of these positions, snap a photo at each step, and download them to your computer. And you have a data set that can then be processed into a 3D model. Jump a bit ahead. You can see that the software interface has a digital twin of the system that mimics all the motions of the real system that is next to you. And for the processing, we use reality capture. You might be familiar with the software that allows us to quite fast and efficiently generate a 3D model that then can be used for e-commerce applications, virtual try-ons, marketing videos, etc. Here you can see an optimized version on the model running in an online browser, Sketchfab. All right. So that was quickly about the Arago system. In case you missed it, we have a unit at the Expo area, just in the next room. So if you want to take a closer look, please drop by our booth after the presentation, and I'll be happy to talk to you and tell you more about it. And now, as promised, we can move to the body scanning. Since we've been working with fashion, we did start getting requests on scanning clothed people for various purposes. And at the time, in the beginning, we only had a limited number of cameras, so an approach with a pole on wheels and moving faster around the subject and asking them to try to stay as still as possible was the only way to go. And as you can see, the results can be quite okay, but it does require a lot of post-processing work in the back in order to clean up the noisy areas that were caused by motion or breathing. So it is achievable, but it's definitely not an optimal method, and it's quite time-consuming to get good results. But luckily, the client was happy, and more projects like this came about. So we were able to put together a full-body scanning system, which at the time comprised of 70 cameras, for which we designed our own electronics to synchronize these cameras, power them, and transfer data for efficient capture. With this system, we traveled to Paris and did a photogrammetric photo shoot for the collection of Fall 21 for Balenciaga, where, because it was the COVID period and the actual fashion show could not be held, they instead opted for making a virtual one using Unreal Engine. However, there were some issues with the system we designed. Since it was done quite hastily and was done for a particular purpose, it wasn't not optimized quite well. So as you can see from the massive cables in one of the images, setting such a system up would require an entire day, and the number of points of failures here is more than I would like to mention. So as we always do, we go back to the drawing board and we start redesigning things by using what we just learned from doing previous projects and the issues that we had. So the current system that we have operational at our studio is a lot cleaner. It uses redesigned electronics, and it allows more reliable synchronization, data transfer, and power to the cameras. And we're still expanding on this technology to make it even more efficient. All right, and with this slide, since we're based in Denmark, we're legally required to make Lego references. So here it is. As you can see, we went through quite a path of designing, going back to the drawing board, redesigning things based on what we learned, and it was valid both for the object capturing system and for the human capturing system. And sort of the biggest takeaway from that is that there's a lot of moving parts, there's a lot of variables and a lot of unknowns. Technology keeps evolving, new cameras come onto the market that need support, new software comes up that can promote new workflows that we need to be able to adjust to. So designing a rigid system that is kind of meant to solve a particular case is not an efficient way to go forward, especially as things are speeding up even more nowadays. So at the moment, the focus of our company is to pretty much take inspiration from the Lego and design sort of individual bricklets that can be compiled and readjusted into very flexible systems that can be tackled for objects, people, potentially environments, and more importantly, that our users and future clients will be able to compile their own systems out of these convenient building blocks that would also have sort of software support that's kind of universal for all of these elements, be it cameras, lights, potentially other scanning devices, motors, motion axes, etc. So with this, I think I'm gonna wrap up my presentation. In case you would like to hear more about the progress and the things we're gonna develop in the future, you can follow us on social media. And if you want to say hi to us, you're welcome to drop by our booth, and happy to talk to you. Thank you.
Thank you, Alex. Very interesting topic. I'm calling questions. There's a question from Christian.
Thank you for a very nice presentation. I'm just wondering, what's the resolution of the final meshes that you get if you haven't mentioned?
This is quite a common question, but the answer is normally it depends. Since we're flexible to decide how close we want to get to the object, we can sort of regulate depending on the use case. If it's something that's going to be heavily optimized to, so say, run online, then we're likely to use less images and sort of be further away from the object, as opposed to if we're doing some close-up renders or sort of more VFX applications that will require a high poly mesh. So it's up to us essentially to decide how how much data we want to collect.
What's the highest quality that you can get? Roughly, just kind of.
Well, in terms of just the raw reconstruction of the polygonal mesh, I think tens of millions of polygons is quite. It's a basic raw output that is unfortunately unusable in most applications, so it has to be decimated pretty much off the bat. But yes, millions of polygons. That's very common, even from a relatively small data set, say 300, 400 images.
More question? No one from online? There is a line there? Okay. Yeah. Go first, Dad.
Thank you for your presentation. My question was, with the rigs, the rig that you designed, I assume it's repeatable, so do you do multi-pass with polarized, non-polarized lenses, etc.? Curious on that.
Correct. That's one of the advantages of having the system that can pretty much go through the same list of positions, is that we're able to use polarization if necessary, or in some cases matting spray to dull down reflections. The system's hardware will not allow for like the pixel perfect repetition, but it's still enough for most photogrammetry softwares to sort of still align the data together, and then you can selectively texture it based on the path that's more relevant to you.
Yeah, and follow-up question. I saw a Nike shoe with a transparent gel, how did you capture that?
Well, this was done using several passes. First of all, it was powdered in order to get the geometry of that translucent thing, and then it had to be remodeled based on that reference and sort of to make it look as it's real. But when it comes to translucent things, unfortunately, there's no easy or even like semi-usable method of scanning these things.
Thank you.
There are a couple of questions online. Let's go to the online first question. Can you pass the speaker to Claudio? Yeah, let's read the first one first. Then we'll go to the in-house here.
Okay, so the first question is, can you scan limb object like clothing or fabrics when turning may induce its movement and deformation?
That's a very good question. It's a very sort of relevant issue that small vibrations, or if the object is prone to deformation, it would create challenges for reconstructing it correctly. What we normally do is we slow down the turntable to its lowest speed, which can minimize this from sort of reduce the chance of this happening. And in some cases, also setting off delays before and after capture for allow the object to stabilize slightly and sort of increase the success rate for these scans. But yes, it is an issue.
And the second question is, how many people are in your scanner engineering team?
It's also a very good question. At the moment, we're 7 people in the company in total.
Thank you. That's an on-site question there, right? No more?
Hey, I have 2 questions. So the first question is, I saw a company from Denmark called Rains, and they're doing 3D on their website. Did you help them?
Rains, I'm not sure I heard about.
And my second question is, how expensive is it for companies to get their shoes scanned? And is there a lot of post-production once they scanned the shoe? Do they send it to you guys, and do you guys do something with the images before they can use it, or is it ready to go?
That really depends on the use case. If we're talking about a regular service contract, then the amount of post-processing would really depend on the specifications that the client gives us. which is normally dictated by the end use case. So whether it's going to be an online viewer, a mixed reality experience, or something else, the sort of the amount of post-processing work would be different, and we can either offer to do it everything end-to-end, or in some cases, companies have in-house expertise that can take part of the process. And this will sort of regulate the price, because obviously just human hours that are spent on these tasks. The amount of post-processing in general depends on also factors such as different surfaces. As we mentioned, like reflective, translucent objects might require remodeling, which is again human time, so it makes it more time-consuming, more expensive for the client, unless they have, again, in-house expertise that they can sort of channel this towards. And when it comes to the system itself, when we sell it as a product, normally most of our clients have the team that will then process the data as they see fit. In the end, the output of the system is just a data set of images. It's sort of calculated to be optimal to get a good result, but when it comes to photogrammetry or any scanning technology, there's no like foolproof solution that's going to work sort of every time on every particular object. So in some cases, pre-processing of the images might be needed, or several passes like polarization or matting spray. Yeah.
Any more questions? Okay, that I'll conclude this session.